Chemical cells, or electrochemical cells, generate electricity by submerging two metal electrodes into an electrolyte. The metals have to have different reactivities for this to work, so you can't use two pieces of the same metal. The cell produces a voltage, or a potential difference, when electrons move from one metal to the other. This movement of electrons produces electricity that can be used to power electrical appliances like a bulb. Metal atoms like to lose electrons, which is called being oxidized. The more reactive a metal is, the more easily it loses electrons, so the more likely it is to lose electrons. That means the electrons move from the more reactive metal to the less reactive metal. In this case, because zinc is more reactive than copper, zinc is oxidized and the electrons move from zinc to copper. The bigger the difference in reactivity of the two metals, the greater the voltage produced by the cell. A cell that uses zinc and copper for its electrodes might produce a voltage of 1.1 volts, whereas if you used magnesium and copper, that's a bigger difference in reactivity, so you'd produce a greater voltage. You get either a positive or a negative voltage. If metal 2 is more reactive than metal 1, the voltage will be positive. If metal 2 is less reactive, the voltage will be negative. In this cell, metal 2 is copper, so it's less reactive than metal 1, which is zinc. That means the voltage will be negative, so it will actually be minus 1.1 volts. If we swap the electrodes around so that metal 2 is now zinc, and that is more reactive than metal 1, that means the voltage is positive, so it will be positive 1.1 volts. The voltage also depends on which electrolyte you use. If you change the electrolyte, you'll get a different voltage for the same metals. You can connect two or more cells together to produce a battery. If you connect a 0.7 volt cell to a 1.2 volt cell, you produce a 1.9 volt battery. We can create a table that shows the voltages produced by cells using different combinations of metals. Cells that use the same metal for both electrodes would not produce a voltage, so these are shaded. We can use this table to put metals A, B and C in order of reactivity. Remember that the bigger the difference in reactivity between the two metals, the greater the voltage produced. The two metals that produce the greatest voltage have the biggest difference in reactivity, so they must be the most reactive and the least reactive. In this table, the greatest voltage is produced by a CB cell, where C is metal 1 and B is metal 2, or a BC cell, where B is metal 1 and C is metal 2. Remember that the voltage is positive when metal 2 is more reactive. The voltage is positive in the CB cell when B is metal 2. This tells us that B is more reactive than C. That means B must be the most reactive of the three metals, and C must be the least reactive. That also tells us that A is in the middle. We can confirm that because the voltage is positive in the Ca cell, where A is the metal 2, so A must be more reactive than C. So in order of decrease in reactivity, B is the most reactive, then A, then C is the least reactive. If the reaction used in a cell is reversible, the cell will be rechargeable. Alkaline batteries use non-reversible reactions, so they are not rechargeable. Here are some practice questions for you to try. Pause the video and give them a go. The two metals used in a chemical cell have to have different reactivities. The greater the difference in reactivity, the higher the voltage produced. If metal 2 is more reactive than metal 1, the voltage will be positive. If metal 2 is less reactive, then the voltage will be negative. To place these metals in order of reactivity, we need to find the combination that produced the greatest voltage. That means the metals used in that combination have the biggest difference in reactivity, so they must be the most reactive and the least reactive. In our table, we get the greatest voltage when we use metals D and E, minus 1.2 volts for a DE cell and plus 1.2 volts for an ED cell. That means that either E or D is the most reactive and the other is the least reactive. Remember that when voltage is positive, as it is in the ED cell, metal 2 is more reactive. That means that D is more reactive than E. So D must be the most reactive, and E must be the least reactive. That also means F is in the middle, and we can confirm this by looking at the EF cell. The voltage is positive 0.6. That means metal 2, which is F, must be more reactive than metal 1, which is E. So in order of decrease in reactivity, D is the most reactive, then F, and E is the least reactive. Finally, alkaline batteries are not rechargeable because the reaction they use is not reversible.